Anybody tried any problem, anything which you are finding it difficult?
I did 11th and 14th one.
11th and 15th. Okay. Are you able to get the answer or not?
Yes, sir, I checked the answer. That's correct.
Okay, very good. Anybody else, any doubts where you are not able to get the answer or not able to understand how to proceed? Any problem you want me to try? Let's see. 5.4, anybody tried it?
5.4.
4.
Sir, I did 5.5, 5.6, 5.8, 5.28, 5.14, and 5.11.
Okay. One end of a string of length L is connected to a particle of mass M and the other to a small peg on a small smooth horizontal table. Smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle directed towards the center is. So I think they mean something like this, like a peg means like something protruding out of the table. And then you have a mass and then it's kind of going around the circle like this. I think that's what they mean here. Mass is m. The particle moves in a circle with speed v. So the speed here is v. Net force on the particle directed towards the center. So net force means on the particle. So it means tension is this way. So I think only the tension will be there, right? Tension v squared by r. So sigma f is equal to ma. So there is no other force, only the tension is acting in the string. So tension is this way. So tension should be equal to mv squared by r. R is your length L. So I think the answer would be just tension T, because the force acting on it is only this one. Okay. Any questions? Five 5.5, did we finish it the other day? Anybody check your notes?
Yes, sir, we did 5.5.
We did 5.5. Okay. What about 5.6? Did we do that?
No, we did 5.7. We didn't do 5.6.
5.7 we did. Okay. 5.6. Anybody having any difficulty? I think it's the easy one.
Yeah,
Any
it's
of you have?
no, sir.
No doubts? Okay, let's quickly go through that. Again, I'm not going to go through, work out everything. The mathematics part, you will have to do it yourself. Constant force acting on a body of mass 3 kg changes its speed from 2 to 3.5 in 25 seconds. Okay, the direction of motion of the body remains unchanged. What is the magnitude of direction of the force? So F is equal to ma. So m is given v minus u by t acceleration. So v is given, u is initial velocity is given, final velocity, time taken is given. That means you can find the force. So you can find the force magnitude using this. Direction, they said the direction of motion did not change. Since the direction did not change, what do you think? The should be in the direction
For
of
the
the,
force acts in the direct motion of the body.
yeah. So the direction should be in the direction of the motion of the object. That's all. Okay, very simple, nothing very difficult there.
So the formula will be F is equal to M into V minus U by T. V minus U by T. Yeah.
5.7, I think you said we already did it, right?
Yes, sir, we did it.
Okay. Your voice is very low. What about 5.8? Driver of three-wheeler moving at the speed.
No, we didn't do 5.8.
So I did this one, sir.
Great. Okay.
Yeah, even I did so.
Okay. Anybody want me to do this, or anybody had any trouble, or is it an easy one? I don't know. The speed 36 km/h, sees a child standing in the middle of the road and brings his vehicle to rest. So that means initial velocity is 36 km/h, final velocity is 0 in 4 seconds. So time taken is given just in time to save the child. What is the average retarding force? So F is equal to MA, same thing. M is given, mass of the three-wheeler and the driver is given. So you have to take the total mass. Acceleration is V minus U by T. So V is final velocity 0. Initial velocity is 36 km/h. Don't forget you have to convert it to meter per second. Okay, because whenever you are putting it in this SI units, you have to take it in SI units.
Minus 2.5 meter per second.
Is that what you're saying?
Yes.
Yes, sir, it's minus
Okay.
2.5 meter per second.
What is the final answer you folks are getting? Retarding force.
Sir, I think I'm getting minus 1162.5.
Yeah, minus
1162.
Yes, sir. Minus 1.16 into 10 to the power 3 newtons.
Minus 1162.5 Newton. Is that right?
Newton.
Yeah.
Yes, sir.
Okay, very good. Anybody have any doubts? Can I move on? Okay, 5.9 we completed. 5.10.
We have to do 5.10, sir. We finished only till 5.10.
Sorry, your voice is very, very low.
So we have to do 5.10.
5.10. Okay. A body of mass 0.4 kg moving initially with a constant speed of 10 meter per second to the north is subject to a constant force of 8 Newton directed towards the south for 30 seconds. Take the instant the force is applied to be t is equal to 0. The position of the body at that time to be at x is equal to 0 and predict its position at t is equal to -5, 25 seconds, 100 seconds. The body of mass 0.4 kg is going initially constant speed towards the north. It's moving with a constant speed of 10 meter per second. North is subject to constant force of 8 Newton towards the south. So 8 Newton towards south. For 30 seconds. Take the instant force t is equal to 0 and predict its position at t is equal to -5 seconds. So -5 seconds means before you apply the force, right? So before you apply the force, 5 seconds before that, where should it be? So let's say you are applying the force in this position. So before 5 seconds, this object should have been somewhere here. So 5 seconds before the time instant, which means no force was acting on it, which means 5 seconds before that. Anybody have the answer? The location. This x is equal to 0. So this must have been s is equal to ut plus half at square. Can I use that?
Yes,
Ut
sir.
plus half at square. So s is what I want to find. U is initial velocity is. So initial velocity is going at a speed of 10 meter per second. It's not access since there is no force initially, right? At minus 5 seconds. And if you are wondering, sir, how can time be minus? All they are saying is when t is equal to 0, you apply the force, which means minus 5 means 5 seconds before applying the force. That's the meaning of this. So don't get confused to know how time can be negative. So acceleration becomes 0. Why? Because there is no force. So no force means no acceleration. So this becomes 0. So initial velocity you are going at 10 meter per second. Time taken is 5 seconds before that. So that means it is 5. So that means it will be 50 meters. That means it should have been 50 meters behind. So x should have been minus 50 meters. Anybody got this? Nobody got that? Okay, take it down. At least now are you folks following it? Time t is equal to 0 means you are applying the force. So this is 5 seconds before applying the force, which means there is no force. Which means it should have been 50 meters behind. Okay. Any questions? That is your A part, the first. B subdivision is 25 seconds. But then the force was applied for 30 seconds. So it means 25 seconds means you have been applying the force continuously. You are applying the braking force, something like that. So that means they're asking you to find the time t is equal to 25 seconds. Where will be the object? Force is applied. So since it is applied till 30 seconds, this is coming under the window of 30 seconds. So that means 8 Newton is acting in the opposite direction. So S is equal to ut plus half at square. So the force applied is 8 Newton. Mass is 0.4. Acceleration is this way. Since it is in the opposite direction, I'm going to apply a minus. So this will be 80 by 4. So it will be 20 minus 20 A meter per second square. U is 10. Time taken is 25 seconds. After 25 seconds, where it is? Plus 1 by 2. Acceleration is minus 20. T squared is 25 square. So do the math and tell me the answer.
Minus 6,000 meter. Converting to kilometers, minus 6 kilometers.
Minus, why minus? Oh. It's already having some velocity. So 10 meter per second. So the acceleration is more than that. It's 20. So after 1 second, it will be 0. After 2 seconds, it will be 0. Okay. What did you say? Minus 6,000 meters. Is that right?
Yes, sir.
Okay. Everyone getting that?
Yes, sir.
So check. So what this means is the object has started moving in the opposite direction. So the important point to note here is, since they said the force is applied for 30 seconds, this was falling within that. So I was able to apply this. Suppose if they have said that the force applied was only for say 20 seconds, then up to 20 seconds I should have used this, and then for the remaining 5 seconds I should not use this. So this is an important, very important concept. So please pay attention and make a box and write it down properly. So I call it as force and acceleration. Do not have memory. Don't have to write this in the exam, but it's only for your understanding. Whereas velocity has memory. What it means is, this is Newton's first law. So if something is going at say 5 meters per second, it will keep on continuing at 5 meters per second forever and ever. Okay, and that is Newton's first law. But what this means is, if I apply 5 Newton for this, velocity continues forever. Okay, but if I take and if I apply 5 Newton here for 5 seconds, only for that 5 seconds this force is applied, which means it will be reaching certain speed. So for 5 seconds, in 5 seconds, let's say it reached say 2 meters per second. So slowly it's increasing 0.1, 0.2, 0.3. So it's reaching 2 meters per second, for example. So after that, after 5 seconds, this force is stopped. So suppose if I say the force is not applied after 5 seconds, what will happen is, whatever velocity is reached here, that will be your initial velocity for the remaining journey. So it will keep on continuing for the same velocity. So this 5 Newton applied in this 5 seconds does not matter here. So it will keep on going. So no force or acceleration here. So very important concept. So take it down. So 10 seconds earlier, if I had applied 5 Newton force, that really does not matter here. Okay. So now what they're asking is, the third C section is 100 seconds. So as I said, the 8 Newton force was applied only for 25 seconds. So the remaining 75 seconds, right, there was no force. So this is where you folks will make mistakes. So make sure you are taking down the notes properly. For remaining 75 seconds, no force was acting. So that means at the end of 25 seconds, what was the velocity? That velocity is going to continue here. So it means at the end of 25 seconds, what is the velocity? Okay, so let me redraw this diagram. So it's here. So x is equal to 0. Then here x is equal to 6,000 meters. Actually, I should say minus 6,000 because it has come backwards. Right, so minus 6,000 meters. So this happened in 25 seconds. So now they are saying another 75 seconds. After 75 seconds, what happens, right? Again, I think I made a mistake here. The previous question was for 30 seconds, right? Previous question was, previous part was 25 seconds. So the force is applied for 30 seconds. Okay, I think I confused you a little bit here. So the force is applied for 30 seconds, not for 25 seconds, which means the remaining 70 seconds we need to find. So can you folks try it now? So this 6000 was for 25 seconds, not for 30 seconds. So what I should do is I should redo this problem again. So x is equal to 0 here. And after 30 seconds, where is this? Maybe I don't need this location, but I need the velocity here. Okay, why? The final velocity v is equal to u plus at. U is, it was going in the positive direction initially. It was going at, what was the speed? Plus 10 meter per second. A is minus 20. Time taken is 30 seconds. So after 30 seconds, where will it be, or what will be the velocity? So 10 minus 600. So it will be minus 590. So after 30 seconds, it will be moving in this direction, backward direction, with the velocity minus 590 meter per second. Everyone getting this? Any errors?
No, sir. Got it.
No issues. Okay, you are also getting this. Okay. So that means I know the velocity here, and after that I need to do another 70 seconds. So that is where I need to find the location. So it means this location is, so I need to find the distance traveled in this 70 seconds. I also need to find the distance traveled in, or displacement in this 30 seconds. So do that again. S is equal to, anybody have the answer for that? S is equal to ut plus half kt square.
Yeah, so minus 590 into 70.
Okay, so initial velocity is plus 10. No, I'm talking about this region, this displacement.
Oh, okay.
Okay, I think you are talking about initial velocity minus 590 means you are talking about the second part. I'm talking about the first
Yeah,
part.
I was talking about.
So 10 time taken is 30 seconds. Don't forget here it is positive, whereas here acceleration is negative. So plus 1 by 2, acceleration is minus 20. Time taken is 30 square. So anybody have the answer for this quickly? 300 minus 10, so 900. 900 into 1000 minus 9000. Is that correct? Yes, 900 into 10 will give me 9000. So this will be minus 8700.
Minus 8,700.
So I know the location for this one. So from 6000 meters in the next 5 seconds, it has moved another 2700 meters. The second part of the journey, S is equal to ut plus half kt square. But very important, what did I say in this 70 seconds? Is there any force acting? They said only for the first 30 seconds there is force. Here there is no force acting. So this is the point which is confusing, and because of my computer screen, I'm not able to show it fully. No force acting. Is this size okay? Are you able to see the letters?
Yes, sir.
So no force acting here. So no force means acceleration is 0. Initial velocity at this point is minus 590. Time taken is 70 seconds. Anybody? Any number? 9, 7, 3, 6, 45 plus 6, 41. Is that right?
4,000. Yeah. Meter.
41,300 meters. So that is the displacement for the second part. The first part is 8,700. So the total will be minus 8,700 minus 41,300.
Minus
From
5,000 meter.
5,000. How 5,000? You mean 50,000?
Oh, sorry, I mean 50,000.
Yeah. Any questions? Any doubts? Anybody not following? So you need to understand that there are two parts in this question for 100 seconds. Up to 30 seconds, the force is acting. After that, there is no force acting, which means there is no memory here for the force and acceleration. So I should not take any force or acceleration from here. But velocity I can take. So whatever is the velocity at the end point, that will be the velocity memory. So with that velocity, it will keep on continuing unless there is any force. And that is because Newton's first law says so. Okay. Or Galileo's experiments and Newton's laws say that when an object is going at a particular speed, it will keep on going at the same speed without any change unless some external force acts on it. Very simple. Only thing you should understand that there are two parts here. So we can also write this as minus 50 kilometers. So that is for your C part, C question. Okay, anybody still copying? Okay.
Copy.
Copied.
Oh.
5.11. Anybody tried 5.11?
Yes, sir.
Okay, you got the answer correctly. I don't see anybody else saying. Veer and Siddharth, are you folks trying out the problems from your textbook?
Yes, sir.
Okay, I'm sure
Yes,
some
sir.
of the questions. I'm sure some of the questions are repeated. So at least take it down and try to understand the concepts. I'm sure when you try your problem in the textbook, it will be useful. The truck starts from rest and accelerates uniformly at 2 meters per second square. At time t is equal to 10 seconds, the stone is dropped by a person standing on the top of the truck. Accelerates uniformly. So let's say that's my truck. And at time t is equal to 10 seconds, the stone is dropped by a person standing on top of the truck. So somebody is standing on top of the truck. 6 meters high from the ground. So it means what are the velocity and acceleration of the stone at time t is equal to 11 seconds. So this is an important concept. Okay, I will send you a WhatsApp video. I don't know if I already sent it. So when something is going at certain speed, right? When the truck is going at certain speed, this ball or stone which he's carrying is also going at the same speed. Which means when he drops it at 10 seconds, right? Within 10 seconds, this truck should have accelerated, which means you can find the velocity. That velocity will be the initial velocity of the stone. Okay, let me say that one more time. A truck starts from rest and accelerates uniformly to 2 meters per second. So, which means after 10 seconds, it will have reached certain speed. So V is equal to U plus AT. So initial velocity is 0, A is 2, time is 10 seconds. So that means it has reached 20 meters per second at time t is equal to 10 seconds. So that means this stone was dropped at time t is equal to 10 seconds, which means the stone is also moving at a speed of 20 meters per second. Anybody have any doubts so far? So when I drop the stone at that particular instant, the stone is also going at the same speed. But then you know that projectile motion means initially uy is 0, but then the gravity is also going to pull it downwards. So what are the velocity and acceleration of the stone at time t is equal to 11 seconds? So what did I say in the previous one? Very important concept. The acceleration force does not have any memory, whereas the velocity has memory. So that means at time t is equal to 11 seconds, right? Which means after 1 second. So after this has happened, anybody not following this? The truck is going this way, which means the ball is also going this way, and you are dropping the stone or the ball. Initial velocity in the y direction is 0, right? Even though the gravity is pulling it downwards. So after 1 second, right, what will happen? It will try to take a projectile motion with this. Then they said that this height from the ground is 6 meters. So after 1 second, right, the ux remains the same. Why? Because the velocity in the x direction does not change. Neglect air resistance, which means the ux does not change after 1 second. But after 1 second, due to the gravity, this uy would have increased. So Vy is equal to U plus At, Uy, Ay. We studied this in the previous chapters. Initial velocity in the y direction is 0. Acceleration in the y direction is 9.8 or 10. Time taken is, we are talking about after this has happened, after 1 second, which means in 1 second it has come here. So 10 meters per second. Any questions, any doubts, anybody? Only if you ask me doubts, you will, I will understand where you are getting stuck. They asked you to find the velocity and acceleration. So that means velocity can be found out using this Pythagoras theorem. So B resultant is equal to square root of Vx square plus Vy square, because both are 90 degrees. If it's not 90 degrees, then you have to do plus 2 Vx Vy cos theta. And then when you say Vx and Vy, it has to be perpendicular.
So it's 20 square plus 10 square.
Yeah, 20 square plus 10 square. So how much are you getting? 400
500
plus
meter per second.
root of 500.
Minus MS 97.
But then velocity means what? Is it magnitude, or should I find the direction also? What do you think?
Direction also.
Find the direction.
Direction also, right? So how to find direction? Anybody?
Using
So that is your theta or alpha. You can call it as theta or alpha or phi, whatever you want. So tan theta is equal to opposite by adjacent. Opposite is this line. This line and this line are same. So that means Vy by Vx,
Vy by Vx, which is 10 by 20,
which
1
means
by 2,
10 by
0.5.
20, which means it is theta is equal
1 by
to
2,
tan inverse of
0.5.
1 by 2. You know tan 45 is 1. So tan 1 by 2 I think will be something close to 30 or no less than 30.
26.56.
26, yeah. So you should know some approximate understanding, okay, so that you will be able to choose MCQ answers. Okay, so that means we found the magnitude of the velocity of the, magnitude of the velocity and then the direction of the velocity. Can anyone tell me how to do the acceleration?
At V is equal to UT, sir. I mean, UV is equal to U plus AT.
V is equal to U plus AT, okay. But we have completed the velocity. We are talking about acceleration. My question for you is
A is equal to V minus U by T. Sorry, sir.
say
A
that
is
again.
equal to V minus U by T.
V minus U by T, okay. But you don't know any final velocity and initial velocity here. Okay, you can do
So
that.
final velocity we found in A part, sir.
What's that?
Sir, final velocity we found it in the A part, sir.
Yeah. Yeah, what you folks are thinking is correct, but let me ask you an important question. The moment you leave the ball, right? It is disconnected from the lorry or the truck. So that means it doesn't have any memory of the acceleration or force. So whatever velocity with which it is going, it's going at the same velocity in the x direction. In projectile motion, what did we study? The Vx direction velocity does not change. So what is the acceleration in the x direction? In projectile motion, we studied that the velocity in the x direction does not change because nobody pulls it from the x direction. The ball is getting pulled only in the which direction?
In the Y direction.
Y direction. So that means now tell me, nobody is pulling it from the x direction. Somebody is pulling it from the y direction. What is the acceleration in the y direction?
So in the Y direction, it's 10 meter per second.
10 meter per second square.
Yes.
9.8 meter per second square. So that means what I'm trying to say here is take it down, the B part. So no acceleration in x direction. Because in projectile motion itself we studied this. So ax is equal to 0. Whereas ay is equal to minus 9.8 meter per second square. That's all. What you folks are telling me is, sir, we know the Vy is 10 meter per second. We know the Vy at this location is 0, which means V minus U is 10 minus 0 divided by time taken is 1 second. So that means 10 by 1 is 10. The same thing. Chaitanya, is that okay?
Yes, sir.
You're not following that? So what you said is true, but you already know the answer that it's acting only due to the gravity, which means the acceleration is 9.8. And using that only, we calculated this Vy, which is 10 meter per second. Anybody not following, please ask me. The moment you leave the ball, right, it is completely disconnected from the lorry or the truck, which means whatever is velocity at that particular instant, t is equal to 10 seconds. That is your memory velocity. So that's why I gave you an important concept. Force and acceleration, no memory. Velocity, yes. memory is there. Because Newton's first law. Many space missions, what they do is they say that the NASA has taken pictures of Pluto, right? How did they take pictures of Pluto? Because they put the rocket or something in one particular direction and keeps on going at the same speed. So if nobody else is stopping it, it keeps on going at the same speed. Okay, anybody still copying?
No, sir, done.
Okay. Okay, any other questions which you want me to do? 5.11, 5.12. 5.12, anybody? Got it right? So Elvin, you're saying something. Satellite sent called New Horizons in 19 January 2006. Okay. Is that the one which was sent towards Pluto or something outside the solar system? To Pluto? Okay. New Horizons. Okay. Okay. Very good. Thank you for that information. A bob of mass 0.1 kg hung from the ceiling of a room by a string of 2 meters long. Set in oscillation. The speed of the bob at its mean position is 1 meter per second. What is the trajectory of the bob if the string is cut when the bob is at one of its extreme position at its mean position? So when it is at extreme position, can anyone tell me what is the velocity here?
0.
0. Yeah. So that means suppose if I cut this thread when it is at the extreme position, right? There is no velocity in the x direction or y direction. At the moment I cut this, is it going to hang in there in the air, or is it going to fall down, or is it going to go up?
It's gonna fall down.
So that means it's going to fall down, right? Of course, I didn't mean to say that, it's going to go this way. So that means it's going to fall down.
So when it falls down, I meant to say that Vx will be 0, sir. Vy will be, it will have a value. Velocity is in y direction, but not in x direction.
Yeah, that's correct. That means the velocity Vx will be 0. Vy will not be 0. Okay, because it will fall down. So Vy is equal to u plus at. So they didn't say the time, so they simply is asking the trajectory. So that means it's going to fall down linearly downwards. What about the second question? It's mean position. So then bob is going at 1 meter per second and suddenly you are cutting this. So what will happen? Is it going to fall down, or is it going to go this way, or which way it's going to go?
So it's gonna go in between.
Between, okay. Say that properly. It's a projected motion, right?
Projected, yes.
So that means you have this as your ux, and this is your gravity. So that means the moment you cut this, this will try to go this way, but then the gravity will pull it this way. So that means it will take a projected motion. So that's what they are expecting you to do. Sure. I don't think there is any numerical here, just a conceptual question. Even though they are given some numbers, they are simply asking only the shape of the trajectory. Okay, as I always say, read the paragraph and make it into a simple drawing to make your brain working. Okay, let's go to the next one. 13 is easy. I hope all of you did that. Is that correct? Anybody did that?
Yes, I did it.
I did. Okay. What about others? Many of you are not opening your mouth at all. Ashwant, tell me.
Sir, I didn't do so.
Didn't do. Did you understand the lift problem? Lift apparent weight concept? You studied that in the theory.
Yes, sir.
<clears throat> 70 kg stands on a weighing scale in a lift which is moving upwards with a uniform speed of the same. So I'll tell you how to do it. So I'm not going to work out the entire problem because it's very easy. Some of you, if you have not collected this handbook, you can check with me. Okay. So either I am available in the center or you can go to my home and collect it there also. So I kept the books in both places. So whichever is closer, you can collect it. So Ashwin, did you understand the theory when we discussed this?
Sir, yes, sir.
Okay, so you know, no doubt in the theory, right? So upwards with the uniform speed. Uniform speed means constant velocity, right? That means R is equal to mg, first part A. Apply this concept and get the answer. Downwards with the uniform acceleration 5 meters per second. So downwards means this way. So that means this is where B. So when the lift is accelerating downwards, you will feel like you are getting lifted upwards, which means the weight will decrease. That's the meaning of this. When the lift is accelerated upwards, you will get pushed downwards, which means the weight will be
The weight will increase.
higher. Yeah, apparent weight will increase. Okay, more accurately, you should say apparent weight is increasing, not the actual weight. So upwards with the uniform motion means that is your C part. What would be the reading if the lift mechanism failed and it hurled down freely under gravity? That means it's cut like this. The rope is cut. So that means that A will become G. So that means A minus G minus A will become 0.
Meaning will feel weightless, sir.
Yeah, weightlessness. Right. I hope I sent you a International Space Station video. So what you experience inside a lift when the rope is cut is same as what you experience in a International Space Station. Only thing here you may get hit by the time the lift comes and hits the ground. Whereas here in the satellite or an International Space Station, it keeps on going around the Earth, so it doesn't hit the ground. So Elvin, you are saying like zero gravity, and what did I say? Others, did I say it's zero gravity?
No, sir. You said that the experience in a free falling lift is similar to that of the passengers in the ISS, sir. So in space there's no gravity. So
Yeah, but you should not say it is zero gravity, right? Because the entire crew and entire International Space Station is falling down into the earth, you know, just like moon is falling around the earth, the satellite is also falling around the earth. So zero gravity may be a wrong word, so we should say weightlessness.
Okay.
Okay, so A, B, C, D, you can do all the three, all the four things. 14, anybody tried this? 14? So T is less than 0. What is the force? So the position is in the same position, right? Which means so let's see. Try this quickly. Let me get some water. Tan T is equal to 0, force on the particle. So it's in the same position, right? Which means it's not accelerating. So since it's not accelerating, what can you say? Force will become 0. Similarly, here also it's not accelerating. So A is equal to 0, so F is equal to 0. Here, can anyone tell me what is this? Is the velocity changing or constant? Remember, this is
It's
position.
changing constantly. The 0 to A.
But this is position time graph, not velocity. So if the position is kind of increasing at a uniform rate. What can you say about the velocity? Velocity is constant or changing?
So between
What did you say?
so velocity remains constant where f is equal to 0.
Yeah. So listen carefully. Position is changing, but then velocity is still constant. Why? Because it's a straight line. So slope is same. Since slope is same, velocity is also constant. Which means acceleration is equal to 0. So that means that means in all the three cases, right? Force is 0. Impulse at t is equal to 0, t is equal to 4 seconds. So what is the impulse here? So
The impulse of particle will remain 0 only as of now. But when it reaches 4 seconds, there's a change. And when the impulse is at 0, uh, v is 0.75. That's 3 divided by 4. So mass is 4 kilos. So that's basically 4 into 0 minus 0.75. That's basically minus 3 kg meter per second when time is equal to 0 seconds.
okay. Annual velocity is this one. Initial velocity is 0. So what is the final velocity here? Anybody know the unit for impulse? What would be the unit for
kg meter per
impulse?
second.
Hmm?
Kg meter per second.
Kg meter per second. Okay.
Kilogram meter
Parts.
second.
Change in momentum, sir. So
Newton second.
Newton second, yeah.
Then
Kg meter per second is also correct because meter per second square and second cancels. But usually we write Newtons. Do the same thing over here. Do it as a homework. Only thing here, the final velocity will become 0. V will become 0. U is V by 4. Okay, so the same thing you will get. Only thing here you got positive, here you will be getting negative. Do the second part also. Okay, so anybody still copying? Any doubts? I'm going to quickly give you the idea for 15th one. With that, we would have finished all this 110th page. So homework is you should have finished the examples by this time. So do start doing 111, page number 111 and 112 also.
Okay, sir.
113. So you have 3 more pages, which is a lot of problems here, but not very difficult. So get started with this. So 111 and 112 is your homework. So try to do it as much as possible. So I told you when you pull it this way, the string is pulling the 10 kg this way, whereas the string is pulling the 20 kg this way. Doing for the first part. So tension is acting this way. The accelerating this way. since I'm pulling it this way and acceleration is also this way, I can take this as positive direction, right? If that is confusing, you can take it this. Then if you draw the free body diagram for the second one, so I have done it for the first part. The second part, they are asking do the same thing when you apply the force on this one. Will you get,
So
will you get
you
this?
wrote 40 Newton, it's 400 Newton.
Okay, thank you. So when you apply the 600 Newton on this block, will you get the same answers or will you get a different answer? Anybody?
Different.
Which one will be different, tension or the acceleration? I think the acceleration will remain the same, right? Because it's the same force and same total mass, which means acceleration will be the same, but then the tension will be different. Okay, so try that as a homework. Let's see. Okay, thank you all. If you have any doubts, stay back. Otherwise, you are free to go. Thank you. Bye.
Thank you, sir.
Thank you, sir. Take care, sir.
Thank you, 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 sir.